of us might have seen people doing time travel in those amazing science fictions, those cool time machines that can take us anywhere in time, may it be past or future. But my question is, that is really possible in reality or not? According to Einstein's theory of relativity, every object makes an equal progress through space-time. But take an example of this object. It is kept stationary. It might not make any progress through space, but it might make much progress through time. But if we somehow manage to propel this object at the speed of light, it would be making a lot of progress through space, but no progress through time, because time would be stopped for this object if it travels with the speed of light. And if it travels faster than the speed of light, then it can make a negative progress in time, which results in traveling into past. But according to modern physics, traveling faster than the speed of light isn't possible for any object. So, traveling into past is impossible for us, and the time defect that comes into play for an object moving faster than the speed of light is known as time dilation, and it is only suffered by objects that move at very high speed, relativistic to the speed of light. To know that how time dilation works, we need to know that what is time and how is time measured. Time is always measured by counting on events that happen in equal interval of time always, like atomic clock rely on vibrations of cesium atoms that vibrate nearly 9 billion times a second. Now, imagine a hypothetical clock which measures time by striking beam of light on its surfaces up and down, up and down. If the clock moves at very high speed relative to the speed of light, the clock has to move horizontally, and the light which bounces on its surfaces has to move with the clock with the same speed that the clock moves. Now, for the observer which is sitting inside the clock, the light is moving only up and down, and the observer which is standing outside the clock has been observing the light's pattern going like this, zig zag zig zag. So for different observer, light is traveling different distances, but the speed of light is same for every observer irrespective of the frame of reference, which is equal to 3 into 10 to the power 8 meters per second. Two different observers are observing different distances traveled by light, so the time for them being observed should be different, as we know the speed of light is same for every observer. The observer inside the clock might be seeing the displacement of light in the vertical direction only, but the observer who is outside the clock might be measuring the displacement like zigzag in this pattern. So time dilation happens for two different observers moving at two different velocities. As I told you in the previous explanation, the speed of light is equal for every observer in every frame of reference. The stationary clock measures time by bouncing light on its surfaces, but when the clock moves, it has to move horizontally, while the light in it also has to move horizontally with the clock, hence resulting in different displacements of the clock in two different situations. Hence, the speed of light is same, so the time has to differ. As my mathematics is correct, you can see that we received a formula for different times measured by the clocks. In this clock, the time measured is equal to t, while in this clock, the time measured is equal to t dash. You can see the relation between t and t dash.